I'd like to start off this series with a very persistent myth. The myth that resistance, like HREZ, always comes at a significant cost. A cost of production, a cost of yield, a cost of plant performance. Something needs to give. So what do we talk about when we talk about resistance? Well, HREZ, it's a quite unique resistance gene. It's called a nibbler. And these resistance genes, they work as sort of recognition mechanisms. The way I like to illustrate this often is, imagine Napoleon was trying to invade Russia. This was one of his foolish mistakes where he went into the winter of Russia and invaded them. And he didn't win the war, but it was not because the army of Russia was huge. It was because those soldiers, those Russian soldiers, they looked in the distance and they saw Napoleon coming. And what did they do? They burned down their entire village and they just went east. So as soon as Napoleon and his troops came there was nothing there to feast upon. They went again to the next time, and then the soldiers again look out, they see Napoleon and his troops coming, burn down the entire village. And this is called a scorched earth tactic, and this is exactly how the plant cell also works. The plant cell recognizes the invader and it just burns down, local cell death, all the surrounding cells, and therefore the virus can no longer utilize the mechanisms of the plant cell. It's called an active resistance mechanism. Welcome in my natural habitat. As a phytopathologist, we often work in these greenhouses. We do a lot of trials for diseases. And here you can see these two plants. This is a normal tomato plant. It will yield some nice red fruits. And here we've got a wild cousin. It's called a HREZ. They might look quite similar now, but after a few months, the fruits will be very different. Will be hairy fruits, unedible, whereas these make very nice fruits. But this is a gold mine for resistance breeding, because in this genetics lies the HREZ gene, the gene that gives us resistance to TOBRFE. But how do we get from this plant to this plant while keeping the resistance? We start with two tomato parents. One is wild and carries the HREZ resistance gene, the other is our tasty, productive tomato, but it's susceptible. When we cross them, we get the first generation. These plants all look very similar. A predictable mix of both parents, and they all carry half wild, half elite DNA. When these plants make their own offspring, the grandchildren if you will, that's when the diversity appears. Some look wild, some look tasty, and only part of them carry HREZ. This is our selection pool. From this group we choose plants that do carry HREZ and look as close to the tasty parent as possible. Then we cross those selected plants back to our tasty parent. Their offspring look even more like elite tomato, but still keep the HREZ gene. We repeat this for several generations, removing more and more wild DNA until only a tiny piece remains, the piece with HREZ. In the end we get an elite tomato line that tastes and performs like the original, but now has the HREZ resistance built in. Hey Walter.
Hey Manus.
How's it going?
Good, how are you?
Pretty good. We just explained a little bit marker-assisted backcrossing, and how that can really speed up resistance breeding in the modern breeding era. Can you say a little bit about what is a marker and how does it actually help the process?
Of course, so actually in this lab we look at DNA, and with these differences of the DNA levels we're trying to make genetic flags. And those little flags we use to create pinpoints in the genome. And those points we try to use to integrate our resistances into new varieties of Enza. So without those markers, breeding is much more slow than what we do now. The identification of the HREZ gene came, of course, with a lot of dedication of the whole team, but also with a bit of luck. The gene was located in a recombinant hotspot, as you call it, that enabled us to quickly identify the gene and to integrate this with the markers into a lead material without negative effect. Understanding genetics.
So what do we take from this? Resistance breeding is a numbers game. It all starts with large populations where all the genetic diversity of your interesting parents are captured. But then how to select the interesting plants from that progeny, that's really where markers come in. And as Walter explained, having these recombination hotspots where a lot of markers can be situated, that really allows us to quickly select the resistance genetics of interest while getting rid of all the junk material that we do not want. So Martijn, we heard about marker-assisted backcrossing, how we can use markers to really speed up the process. Can you say something about what that brought us in our tomato breeding programs and what you see the future to be for HREZ?
Yeah, for sure. Thanks to this MLBC process, we could integrate our resistance, our HREZ resistance, into an existing varieties. So that enables us to go warp speed. We really went fast because ourselves as breeders, but also our marketing sales colleagues, our customers, they already knew the variety.
And can you speak to the value of having this flag where sort of the marker is positioned within the genome, that's very small, the small integration versus a large integration. What actually does that do for you as a breeder?
To have a flag on the DNA, which we know this is a very tiny fragment, it's of utmost importance to go fast, to not have genetic drag, to only need to follow a small piece of the DNA. So at this moment, we added HREZ in all our elite lines, but that's the basis. We now have a set basis with resistant material, and from here we focus on making the best varieties for our growers in yield, quality and post-harvest.
So, what's true about this myth? The myth that resistance always comes at a significant cost for yield and production. Well, we saw how the resistance mechanism works. It's the scorched earth tactic that the plant plays with the virus. Local cell death only when the virus is present. And otherwise it just sits there quietly in the background, this HREZ gene. And we also saw, through conversations with our colleagues Walter and Martijn, that if you have a smart breeding strategy and you use a very tiny introgression of the resistance, there's no linkage drag, there's no junk DNA from your original parent that has the resistance. And therefore, we can conclude, in the case of HREZ, resistance does not need to come with a cost.